This wonderful plot is from the IPCC and other places. This is a different scale. Today is over here on your right, and the 400 over here is 400 million years, not 400 years, 400 million years. So this is really deep time. And what you have plotted on here are two different things. At the top, hanging down in blue, is the extent of glaciers at a time. And so there were no ice on the planet, basically at sea level, and then there was a little blip of glaciers and they went away, and then the glaciers went way down towards the equator, not all the way by any means, but they got more than halfway there, and then they melted away into a time with no ice near sea level, and then the glaciers have come back, and we have ice in Antarctica and Greenland today. So there's the history, and you could think of this as a history as temperature. There was no because it was warm, there was ice because it was cold, there was no ice because it was warm, there was ice because it was cold. Okay? Shown below is the history of CO2. And what you'll notice is when there was no ice, CO2 was high. And this is estimated in various ways. But what you have here is this high CO2 back here in a no ice time. And then when CO2 got low, the ice had grown. And when CO2 went back up to being high, the ice had melted away. And when CO2 got low again, the ice had grown back. And it turns out there's actually a little dip in CO2 right here that goes with this little blip of ice. And so what we see is a very nice relationship. High CO2, little or no ice, low CO2, lots of ice. Furthermore, we understand from processes that you can read about in our course and elsewhere that it is the CO2 causing the changes in ice, and not primarily the ice causing the changes in the CO2. And this is something you just can't see from this correlation, but we get it from other sources. Now, try to walk you through a few events in climate history. We're going to start with this one back here, the Great Dying, a time when volcanic CO2 raised the temperature and seems to have made it so hot near the equator that large creatures couldn't live there. We're then going to walk you into the Pliocene-Eocene thermal maximum, a time when some formerly living carbon came out of seafloor methane or other sources, belched out fairly rapidly and made it warm. And we'll finish up with the Ice Ages. This is a time when features of Earth's orbit have driven temperature changes, but those temperature changes have been amplified and made global by CO2.